Implementation of file access methods. This section is about how the different access methods to data in files can be put into practice. There will not be a lot of detail, and some questions will remain unanswered. Don't worry, because those will appear in further work. Serial access. Serial files have no order, no aids to searching, and no complicated methods for adding new data. The data is simply placed on the end of the existing file, and searches for data require a search of the whole file, starting with the first record and ending either with finding the data being searched for, or getting to the end of the file without finding the data. Sequential access. Because sequential files are held in order, adding a new record is more complex, because it has to be placed in the correct position in the file. To do this, all the records that come after it have to be moved in order to make space for the new one. E.g., a section of a school pupil file might look like this. Hameed, Ali, 21. Khurram, Saeed, 317. Khwaja, Shaffi, 169. Nighman, Yasmin, 216. If a new pupil arrives whose name is Hina, space must be found between Hameed and Khurram. To do this, all the other records have to be moved down one place, starting with Nighman, then Khwaja, and then Khurram. Hameed, Ali, 21. Khurram, Saeed, 317. Khwaja, Shaffi, 169. Nighman, Yasmin, 216. This leaves a space into which Hina's record can be inserted and the order of the records in the file can be maintained. Having to manipulate the file in this way is very time-consuming, and consequently this type of file structure is only used on files that have a small number of records or files that change very rarely. Note, why is it necessary to move Nighman first and not Khurram? Larger files might use this principle, but would be split up by using indexing into what amounts to a number of smaller sequential files. Example, the account numbers for a bank's customers are used as the key to access the customer accounts. The accounts are held sequentially, and there are approximately 1 million accounts. There are 7 digits in an account number. Indexes could be set up which identify the first 2 digits in an account number. Dependent on the result of this first index search, there is a new index for the next 2 digits, which then points to all the account numbers, held in order, that have those first 4 digits. There will be one index at the first level, but each entry in there will have its own index at the second level, so there will be 100 indexes at the second level. Each of these indexes will have 100 options to point to, so there will be 10,000 blocks of data records. But each block of records will only have a maximum of 1,000 records in it, so adding a new record in the right place is now manageable, which it would not have been if the 1 million records were all stored together. Random access. To access a random file, the data itself is used to give the address of where it is stored. This is done by carrying out some arithmetic, known as pseudo-arithmetic, because it doesn't make much sense on the data that is being searched for. E.g., imagine that you are searching for Jawad's data. The rules that we shall use are that the alphabetic position of the first and last letters in the name should be multiplied together. This will give the address of the student's data. So, Jawad equals 10*04 equals 40. Therefore, Jawad's data is being held at address 40 in memory. This algorithm is particularly simplistic, and does not give good results, as we shall soon see, but it illustrates the principle. Any algorithm can be used as long as it remains the same for all the data. This type of algorithm is known as a hashing algorithm. The problem with this example can be seen if we try to find Jahid's data. Jahid equals 10*04 equals 40. The data for Jahid cannot be here because Jawad's data is here. This is called a clash. When a clash occurs, the simple solution is to work down sequentially until there is a free space. So, the computer would inspect address 41, and if that was being used, 42, and so on until a blank space. The algorithm suggested here will result in a lot of clashes, which will slow access to the data. A simple change in the algorithm will eliminate all clashes. If the algorithm is to write down the alphabetic position of all the letters in the name as 2-digit numbers and then join them together, there could be no clashes unless 2 people had the same name. Example, Jawad equals 10, 01, 23, 01, 04 giving an address 101230104. Jahid equals 10, 01, 08, 05, 05, 04 giving an address 10010805050. For the problem of clashes has been solved, but at the expense of using up vast amounts of memory, in fact more memory than the computer will have at its disposal. This is known as redundancy. Having so much redundancy in the algorithm is obviously not acceptable. The trick in producing a sensible hashing algorithm is to come up with a compromise that minimizes redundancy without producing too many clashes.